Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to discuss logarithm. Logarithm, it is section 2.3.3. If you remember at the beginning of this section, we discussed exponent or indices. And we stated if the number m is expressed as m equals p to the power n, m equals p to the power n. We called p the base, if you remember, and n the power indices or exponent. This is an exponent occasion, okay? Because I have base and power. So p to the power n is called the exponential form of m to the base p, or we can read it m equals p to the power n. But again, we are talking today about logarithms. So what is the relationship between logarithms and exponential? Well, let me start by finding out the relationship between exponential and logarithm. Suppose that I have exponential occasion 2 to the power 3 equals to 8. This is exponential occasion. I'm going to introduce the corresponding logarithmic occasion of this exponential occasion. So I'm going to write log, then equals 3, 8, and this is 2. So if I have exponential occasion 2 to the power 3 equals to 8, then the corresponding logarithmic occasion is logarithm 8 at the base of 2 equals to 3. 2 to the power 3 equals to 8, then logarithm 8 at the base of 2 equals to 3. Let me give you another example. What if I have 3 to the power 4 equals 81? This is exponential occasion. Okay? What is the corresponding logarithmic occasion? Log 81 at the base of 3 equals to 4. Let's have another question, another example. What if I have 2 to the power 6 equals 64? This is exponential occasion. Now, the corresponding logarithmic occasion or equivalent logarithmic occasion, log 64 at the base of 2 equals to 6. Now, if I just highlighting the relationship between exponential form and the logarithmic form, in each time I notice that logarithm equals, in the first occasion, logarithm equals to 3. In the second occasion, logarithm equals to 4. In the third occasion, logarithm equals to 6. If we go back and check what 3, 4, and 6 represents in exponential occasion, we see that 3, this is a 3, it is the power. Also 4, this is 4, it is the power. Same thing, 6, it is the power. So what is logarithm? Logarithm, it is the power to which, again, it is the power to which the base, this is the base, and this is the power to which the base should be raised to in order to yield the given number. So this is logarithm. Logarithm, it is the power to which the base should be raised to in order to yield the given number. So this is the simple definition of logarithm. Now the reverse of exponential occasion, it is logarithmic form. Again, if I have, go to similar or general case, if I said that p to the power n equals to m, this is exponential form. Now the equivalent logarithmic form, log, I said the log equals to power. So what is the power here? It is n. So log equals to n. What is the base? The base is b. So I'll have the same base here for logarithm, and m, it will be in front of logarithm. How can I read this? I read them logarithm m at the base of b equals to n. Logarithm m at the base of b equals to n, no matter how much m, b, and n. So the reverse process of exponential, it is logarithmic form. Again, logarithm m at the base of m equals to n. Logarithm m at the base of p equals to n. Don't forget that p to the power n equals to m. So the logarithm equals to n, where n is called the logarithmic of m to the base of p. So n is logarithm of m to the base of p, or at the base of p. Now let us solve or have some examples in which we are using logarithm in solving some simple questions. Now evaluate logarithm 9 at the base of 3, number b, logarithm 2 at the base of 4, and logarithm 1 over 7 at the base of 7. Let's start with logarithm 9 at the base of 3. Now we will assume that logarithm 9 at the base of 3 equals to n. Okay, logarithm 9 at the base of 3 equals to n. We'll use the definition to convert to exponential form. So don't forget that, again, don't forget that if you have p to the power n equals to m, then log m at the base of p equals to n. Just take this logarithm n at the base of 3. I'm going to assume that it equals to n, which is the power. So I want to find out what is this power. So we'll go back down here, logarithm n at the base of 9 at the base of 3 equals to n. Now I'm going to convert from logarithmic form to exponential form. So the equivalent exponential form, it is 3 to the power n equals to 9. 3 to the power n equals to 9. If logarithm m at the base of p equals to n, then p to the power n equals to m. P to the power n equals to n. So I'll go back here. Logarithm 9 at the base of 3 equals to n. So n equals 3 to the power n. Now I have the right hand side, I have the base, and I have power. At the left hand side, I have 9 is the base and the power is 1. But if I could make the two bases from right hand side and left hand side the same, then the power will be the same. So I'm going to write 9 as 3 to the power 2. I know that 9 it equals to 3 to the power 2. So the left hand side will be 3 to the power 2, right hand side 3 to the power n. Same base, so the power should be equal. If I have the same, this is occasion, left hand side, right hand side, and there is equality between them. If the bases are equal, then certainly the power or exponent or indices should be equal. So n for this problem equals to 2. So if log 9 at the base of 3, this is equal or it equals to 2. Now let's go to example number B, log 2 at the base of 4. Now log 2 at the base of 4, again, we will say that log 2 at the base of 4 equals to n. And I'd like to find out how much is n. We said n, it is the exponent or the power, and it equals to logarithm. Again, I will convert from logarithmic form to exponential form. So log n at the base of 4 equals n, then 2 equals 4 to the power n. Again, we'll use the same procedure. I'm going to make sure or try to make the two bases are equal. I have the left hand side 2, and 4 can be written as 2 to the power 2. So finally 2 equals to 2 to the power 2n, because I have here 2 and we said power to the power, it becomes multiplication. So I have 2 times n, it will be 2 to the power 2 times n to n. So this is 2 to the power 1 equals 2 to the power 2n. From this we can use the simple relationship to n equals to 1 or n equals to half. So the second answer, or the answer of the second question, is n equals to half. Okay, let's go to third question. Log 7, log 1 over 7 at the base of 7. Again, we are going to assume that log 1 over 7 at the base of 7 equals to n. Then we will start writing or convert to exponential. If log 1 over 7 at the base of 7 equals to n, then 1 over 7 equals 7 to the power n. 1 over 7 equals 7 to the power n. Now, just note that this is 1 over 7, and 7 here is to the power 1. If I just raised 7 to the power 1, I shift it from down to up, from denominator to numerator, then it will be 7 to the power minus 1. So finally, I have 7 to the power minus 1 equals to 7 to the power n. Again, I have the same basis, 7 and 7, so certainly the power will be the same, so n equals to minus 1. So this is simple. Problems can be solved by the switching between logarithmic form and exponential form. Let's go back and study the important, or the rules of logarithm, and see how much these rules are important in solving many problems in mathematics. The first rule: if you have inside logarithm, I'm going to say inside logarithm, you have a product of two numbers or two variables. So if you have log xy at the base of b, log xy, this is multiplication, okay? Log xy at the base of b, so it will be log x at the base of b plus log y at the base of b. This means that, note this, this means that the multiplication switch to addition. Multiplication inside logarithm, it turns to addition outside the logarithm. I have at the left hand side one logarithm. Inside this logarithm, I have multiplication. On the right hand side, I will have two logarithms, and those two logarithms, there is plus between them. So multiplications become addition. Multiplication becomes addition. So this is the first rule. Multiplication becomes addition. I can have just small example. If we are using our logarithm, or the logarithm that we have on our calculator, this is called common logarithm, and it has a base of 10. You can try this. If I said log 10 multiplied by 100, okay? Based on this rule, it will be log 10. Of course, here it is base of 10, and there it's also, it will be base of 10 plus log 100 at the base of 10. So if you use your calculator, you'll find that log 10 times 100, 10 times 100, you can write 1000. So this is 1000. If you use your calculator, log 1000 at the base of 10 equals to 3. So the left hand side equals to 3. Now check how much is log 10 at the base of 10. This is 1 plus log 100 at the base of 10 equals to 2. So as you see, 3 equals to 1 plus 2. This is for the first rule. The second rule, it is division. If you have log x divided by y, or x over y at the base of b, then this is log x at the base of b minus log y. So here, division turns to subtraction. Division turns to subtraction. Let me just erase the first problem, just to concentrate on the second rule. So again, division becomes subtraction. Division, it turns to subtraction. Let's have another simple example. Suppose that I have log 1000 again divided by 100. Based on this rule, it will be log 1000 minus log 100. Of course, all of them at the base of 10. This is base of 10, and this is also base of 10. Now, log 1000 divided by log 100, it is log 10, and log 10 equals to 1. So the left-hand side equals to 1. The right-hand side, log 1000 equals to 3, minus log 100 equals to 2. So obviously, as you see, 1 equals 3 minus 2. So this is regarding the second rule. Let's go back to the third one, and the third one is very important, and as you will see in next section, we are going to use this rule many times in order to solve problems involving logarithm. Rule number 3, it's saying that if you have log x to the power m at the base of b, then this power, it becomes to multiplication or coefficient of the log. So m here, it will go and it will be multiple of logarithm. So it will be m log x at the base of b. So the power here, it will go and will become multiple of log. So it will be log x at the base of m equals m log x at the base of b. M log x at the base of b. Let's have a simple example. What if I have log, this is for this example, log 10 to the power 3 at the base of 10. Based on this rule, rule number 3, this equals to 3. We said that 3 will come here. 3 log, well, should I log 10 at the base of 10. Now this will be log 10 to the power 3. This is log 1000. 1000 log 1000 the base 10 equals to 3. The right hand side will be 3 multiplied by log 10 at the base of 10, 1. So 3 equals 3 times 1. So as you see, these are some rules, important rules in logarithm. Now, actually, these are the 3 most important rules in logarithm, but I can add 2 more rules or 2 adjectives for logarithm. You can call it as you want. Now, log b at the base of b always equals to 1. Always. No matter how much is b. If you have log 10 at the base of 10, this is 1. Log 5 at the base of 5 equals to 1. Log 13 at the base of 13, it equals to 1. So let me call this rule number 4, and rule number 5, the last one, log 1 at the base of b, no matter what is the value of b, equals to 0. So log 1 at the base of 10, 0. Log 1 at the base of 5, 0. Log 1 at the base of 100, this is 0. So we can consider that we have 5 logarithms. Okay, we want to use the rules of logarithms to simplify or to express each of the following as a single logarithm. I'm going to use the 3 rules that we discussed before. Number 1, if you have log x plus log y minus log z, I have plus, and don't forget that rule number 1, multiplication becomes addition, and also you have minus, and minus, it comes from division. So log x plus log y, it can be written directly as log x minus y. Y minus z log x, so I'm going to write it log xy divided by z. So plus, it turns to multiplication, minus, it turns to division. So log x plus log y minus log z, all of them have the same base b, it equals to log xy over z at the base of b. So I just simplified the expression. Instead of having 3 terms, now I have just 1 term. At